Recently, I had the unique chance to pilot a military-grade drone, the very same model that Ukrainian forces deploy on the battlefield. How did it go? Well, I managed to crash it within just 10 minutes, taking part of the training facility's ceiling down with me. Oops, my apologies for that mishap. But this entire experience reveals something crucial about Western military production today. Let's take a step back first. Currently, Western nations are ramping up their military spending significantly. Part of this increase is in response to the growing threat Russia poses in Europe. Another factor is the less obvious but still serious threat from China in the Indo-Pacific region. Additionally, NATO allies are committed to raising defense budgets to 3.5% of GDP, partly to appease past pressure from the Trump administration and partly to better prepare for these emerging threats. Beyond that, the global community is learning what specific military hardware is essential for success on modern battlefields. This brings us to the main focus of today's discussion: drones. There is widespread consensus that drones will play a pivotal role in future warfare. Even if there's debate on whether large military forces like the United States or NATO will experience the kind of static frontline seen in Ukraine, the sheer scale of drone use there is staggering. Estimates suggest that roughly 250,000 drones are deployed in Ukraine each month. Imagine how many more would be needed if NATO forces engaged Russia across a much broader front. Then consider the defense of Taiwan, which could require tens of millions of drones alone. When it comes to defense production, there are essentially three approaches to managing drone supply. The first approach is to wait for a crisis to occur before ramping up production. This strategy continues the just-in-time manufacturing model that has characterized weapons production since the Cold War ended. The main criticism of this approach is that we are no longer in a post-Cold War world. We are now in a second Cold War, and it's critical to have military equipment ready in advance, rather than scrambling to produce it during conflict. The penalty for waiting is especially harsh in the initial stages of a hot war, where the adversary's stockpiles are already in place and you are left scrambling. However, there's an even deeper problem with the wait-and-see strategy. China dominates the global market and supply chains for drone manufacturing. This dominance stems partly from a well-known history. Western manufacturing shifted overseas decades ago, with China benefiting the most. Less well-known is how the war in Ukraine has indirectly subsidized China's expansion of its drone manufacturing capabilities. It wouldn't be surprising to learn that Russia depends heavily on Chinese drones. Given the so-called limitless friendship between Russia and China, that would be expected. What's more surprising is that China also supplies Ukraine with drones, both finished non-lethal models and critical components for lethal ones. Apparently, China's business interests don't stop it from supplying both sides of the conflict as long as profits are involved. Ukraine, however, is aware of the long-term risks of relying on China. If the current war ends but later resumes as part of a larger global conflict, China's strengthened position in drone production could cause severe problems for Ukraine. But when your nation's survival is at stake today, long-term strategic concerns often take a back seat. Western countries, however, need to be deeply concerned. If China were ever to invade Taiwan, all these supply chains from the mainland would disappear overnight. The reality is that the West does not currently have the capacity to produce tens of millions of drones without Chinese support. Even as the next major conflict is limited to Europe, there's no guarantee China would maintain its profit-driven stance in that war. Beijing might see NATO attrition as a positive development that facilitates its ambitions in Taiwan later. Therefore, whether the conflict unfolds in Europe or Asia, the Western coalition faces serious challenges if it delays drone production until a war begins. This brings us to the second option: stockpiling drones now in preparation for future conflicts. A useful analogy is the 155mm artillery shell. Since the start of the Ukraine invasion, there has been a massive demand for these shells, and Western countries have spent years scouring the globe for every available round to send to the front. After the war, production will ramp up to create stockpiles for the next conflict. So why not apply the same logic to drones? There are two main issues with this approach. First, it's unclear whether China would allow large-scale stockpiling. Suddenly increasing orders for drones and parts from Chinese manufacturers would likely raise alarm bells in Beijing. Even if China approved, there's a more fundamental problem. I am fairly confident that a 155mm shell manufactured today will be nearly as effective 5 years from now. By contrast, drones are evolving so rapidly that it's hard to guarantee their relevance over time. Battlefield innovations and countermeasures are advancing at a breakneck pace. If the United States started stockpiling drones now, it's entirely possible Russia or China would develop counter-technologies that render those drones obsolete by the time they're deployed. Even more critically, drone effectiveness is extremely sensitive to range. If my drones can fly just a few kilometers farther than yours, I can strike your operator safely while remaining out of your reach. This advantage would allow me to advance steadily while you struggle to respond. Everyone agrees that drone technology will improve. Microchips will become smaller and more powerful, communication systems will enhance, and drone bodies will get lighter, tougher, and more capable. Therefore, stockpiling drones today means risking being outmatched by superior models developed later. The drones won't be completely useless, but the situation is not like with artillery shells. A drone's value diminishes the moment it leaves the assembly line. This leads us to the third option, a middle path that is somewhat perplexing. You can't wait for a crisis to begin manufacturing drones, but you also can't mass produce and stockpile them now without risking rapid obsolescence. The compromise is to focus on developing drone technology and supply chains today. The goal is not to build huge stockpiles, but to create the infrastructure needed to rapidly ramp up production when war breaks out. One key understanding is that supply chains cannot be established overnight. Unsurprisingly, removing China from the supply chain is easier said than done. How to accomplish this is complex enough to warrant its own detailed discussion, which I hope to cover in a future video if things calm down by 2026. For now, it suffices to say that addressing supply chain vulnerabilities before a conflict is far better than attempting to fix them in the middle of one. Moreover, money can solve many of these problems, though that topic deserves its own analysis as well. Another crucial aspect is human capital. People need to be trained to assemble and operate drones, and this requires practice. Unfortunately for Western budgets, this means allied nations must build a significant number of drones, not just for stockpiling, but to develop supply chains and train personnel. At the same time, stockpiling too many drones leads to their rapid devaluation. This raises the question, what should be done with all these drones? Part of the answer is to use them for training military forces, just as rifles and ammunition are used for practice. This brings me back to my own drone accident. Recently, I visited Neuros Technologies to learn more about the current state of drone operations. Traditionally, just under half of the drones they produce are sent to the battlefield in Ukraine. Test piloting one of their drones was a small but memorable part of my visit. Let's watch that security footage again. Yes, the ceiling came down unexpectedly. Apologies to anyone who missed this because they were out walking their dogs. Wait, it gets better if you zoom in on my reaction. While I was momentarily considering how quickly I could exit the facility without being charged for the damage, notice the reaction of Neuros' CTO, Olaf Hichwa. He found the entire incident quite amusing. This kind of crash is routine. Pilots in training typically wreck 5 to 10 drones per day. During my brief time flying, the hardest part was managing altitude. Unlike many video games with drones, there is no joystick that directly controls height. Instead, the stick only adjusts the propeller's RPM. To keep the drone level, you can't simply pick an altitude and hold the stick steady. If a gust of wind lifts the drone, you must reduce propeller speed to stabilize it. The problem is, the controls are highly sensitive. While this sensitivity is advantageous for skilled pilots in combat because it allows flexibility, it's not helpful for beginners. For me especially, it was difficult because I grew up with inverted flight controls, learning barrel rolls and bombing techniques simultaneously. So when the drone lifted, my instinct was to push the joystick upward as well, which inadvertently sent it crashing into the ceiling. I was briefly horrified, thinking I had destroyed a $2,000 drone. Thankfully, only some plastic parts were broken. For someone knowledgeable about drone construction, repairs are straightforward, and replacement parts cost less than $100. The expensive components, the microchips at the core of the drone, remained intact. However, becoming a proficient drone pilot isn't an overnight achievement. It takes approximately 2 months of training to reach combat readiness. factoring in the 5 to 10 crashes per day during training. This training requires a continuous stream of drones from the factory to form effective squadrons. Even then, the current production rates are nowhere near sufficient to build the Western drone infrastructure necessary before a large-scale civilizational conflict erupts. This is where Ukraine's role becomes critical. Ukraine not only needs to continuously train new drone pilots, but also requires more drones for actual military operations. The bureaucratic framework to support this is starting to take shape. Latvia and the United Kingdom have established a drone coalition precisely to meet this need. Yet success demands more funding. Manufacturers must expand capacity. For instance, Neuros Technologies is preparing to move into a much larger warehouse to increase production. The upside of donating drones to Ukraine, or selling them at discounted prices, is that it advances a fundamental mission, shifting the production line to the right to benefit the Western coalition. This approach effectively flips the current war's dynamic. Instead of the conflict subsidizing Chinese drone production, it subsidizes allied drone manufacturing. For a Pentagon increasingly worried about potential conflicts in the Indo-Pacific, this strategy may be essential. I want to thank Neuros Technologies once again for their patience and understanding, and apologize once more for the ceiling incident. Meanwhile, there's no need to apologize for what comes next. 2 excellent books about the war that provide deeper insights. You can find details about them in the video description. If you enjoyed this video, please consider liking, sharing, and subscribing. I look forward to seeing you next time. Take care.